What's going on, guys? In this video we are going to see how to find out the mode of operation of a BJT assuming this is in saturation mode. There are two methods we can use. The first method is we can assume this is in active mode and solve for it, or we can assume this is in saturation mode and solve for it. In both way we can get the same conclusion. Now if we assume this is one in saturation mode, there are two things we have to remember. That if it's in saturation mode, then VBE is equal to 0.8 voltage. This is in saturation, and VCE saturation is equal to 0.2 voltage. And if you assume this is in active mode, this VBE is 0.7 and there will be nothing for VCE. Okay, that's the difference. Now since we are assuming this is in saturation mode, we have to take these two into consideration. And then if it's BE mean base emitter, we know this is base, this is collector, this is emitter. Base emitter is 0.8, so plus minus 0.8 right here. And then VCE, collector emitter, that is 0.2, so collector is this one, plus minus this is 0.2. now first we have to redraw this circuit in a different way to make it easier to solve. So I'm going to go ahead and draw this one again. If we redraw this one, it's going to look like this. Okay, here what we do is we connect everything to the ground. Okay, now we connected this 3 to the ground. Now here we have 5 voltage. Let's go ahead and draw that one. This one is 5 voltage right here, and here we have 10k ohm. And this is 0.8 voltage, and here we have 0.2 voltage. 0.2 voltage. And this one is here we have 1k ohm resistor, and then here we have 8 voltage. Okay, that's all we have to know. Now in order to solve this one and prove this is in saturation mode, we have to compare this one, beta and beta minimum. I forgot to mention, okay, actually beta is already given. This is our beta. Beta and beta minimum, we have to compare these two. And if the beta is greater than beta minimum we have to calculate. If beta is greater than beta minimum, then this is in saturation. That's the condition we have to check. Beta is 100. To find out beta minimum, we have to know two things. We have to find out IC, that is collector current. This is our collector, so we have to find out what is the current through this one, and that one divided by IB. This is the beta minimum equation. To calculate beta minimum, we have to use this equation. B is base current, IB this one. So here this is our IB, and whatever the current going through this is IC. Okay, now let's go ahead and find what it is. So first let's apply KVL to find out these currents. So let's apply for this loop. If I apply KVL for this loop, this is going to be negative 5 voltage plus IB times 10k plus 0.8 voltage should give us 0. Now negative 5 plus 0.8 is negative 4.2. If I bring to the other side, that's going to be plus 4.2. Therefore IB is going to be 4.2 divided by 10k, that's equal to 0.42 milliampere. Okay, now we found out IB. The next thing is we have to find out IC. To find out IC, again I'm going to apply KVL in this one. Let's use a different color to solve this. If I apply KVL for this one, here we are going to have -8 voltage and plus IC times 1K. Then after that it's going through this 0.2 plus 0.2 is equal to 0, and 8 minus 8 plus 0.2 is 7.8, negative 7.8. If I move to the other side, that's positive 7.8. IC times 1K is equal to 7.8. Therefore IC is equal to 7.8 milliampere. Now we have IC and IB, and we know that beta minimum is IC over IB. IC is 7.8 milliampere divided by 0.42 milliampere, and milli cancels, and finally we will get 18.57. Now if we compare beta and beta minimum, beta is 100 and beta minimum is 18.57, and we have beta minimum that is less than beta. That's what we have to prove. If we can prove this one, it means the transistor in saturation mode. So the mode of operation is saturation, and that's how we do that. I hope you guys find this video helpful. Thanks for watching, and if you are trying to learn electronics or circuit analysis, there are a bunch of videos in my playlist. I hope you guys watch that too, and don't forget to subscribe. See you next time.